So problem 30 is a parabola. Y is squared. That's not what we're used to seeing with a parabola. It's usually x squared, or at least it was when we first learned it. So we know that this guy here is a horizontal. It's going to open to the right or the left. Knowing this, it's going to open to the left. So it's horizontal, specifically 1 over 4p. It's a negative 3 that turns that into a 1 over 12. So negative 3 is our p value. It means the focus is going to be 3 units away from the vertex. The vertex, if I wanted to write this as x minus 0, 0 comma 1 is the vertex. Okay, and if we're going to go 3 units to the left of that, well, it would be negative 3 comma 1. So let's take a look at that. There's a point right there. That's your vertex. 3 units to the left of that, 1, 2, 3. I usually mark that with an X, so I can see the focus is different than the vertex. But that would be a negative 3 comma 1. 3 units to the left. To get to the directrix, we're going to go 3 units to the right. 1, 2, 3, the opposite direction. And a directrix is a line that crosses perpendicularly from the axis of symmetry, which we'll talk about in a second. That crosses the x-axis at 3. That's that line there. The horizontal one that goes through there is where these have something in common. That is the y equals 1 combo. So the one thing that's missing is the drawing of the picture. 1, 2, 3, 4, 5, 6. If you count out 6 units, or 2 times the p-value units, I should say, in both directions from that x, you end up with pretty good look at the shape. It's not the best drawing I've ever made in my life, but that's what we're looking at there. Also sketching and writing the equation of an ellipse with vertices here and here and a co-vertex there. Well, this is really to kind of help you out. 4, 1. 1, 2, 3, 4, and up 1. There's a dot right there. If you look at negative 6, 1, 1, 2, 3, 4, 5, 6, and up 1, you can kind of tell that the vertex is right in between. If you add those two things together, 4 and negative 6, you end up with a negative 2. You find the average, you divide that by 2, you get a negative 1. So the center's at negative 1 comma something. Okay?
Christian Lozano, report to the guidance office. Christian Lozano, come to guidance.
And I say negative 1 is the average of the x value. If you look at the y values, they're both 1s. So negative 1, 1 is our center, and that's what I've identified here. Well, negative 1, 0 is actually on the x-axis. That's only 1 unit below, and if I were to go 1 unit above, I could kind of see my ellipse there. And so there's the shape of the ellipse you've got. It's a very squished one. If someone sat on a circle, it's kind of what it would look like. But the key thing to remember is an ellipse basically looks like that. That's your equation of an ellipse. We happen to know our center is at negative 1, 1. So I go x plus 1, which is changing the sign of that negative, and then x minus 1, which is, y minus 1, is keeping the sign of that one there. Now the question then is, how far back and forth are we going? How far up and down are we going to get to the points on the ellipse? So from here back to negative 6, or from here up to positive 4 is a distance of 5. You square that, you get 25. If you go up and down 1 unit, 1 squared is equal to 1, and so there's your equation of an ellipse.